I am Karl Seydel, and I am going to walk you through Project 3, the malaria pathogenesis portion of the Malawi ICEMR, which is entitled Infection Outcomes. The goals of this study are to characterize both the host and the parasite features that are contributing to the three possible outcomes of asymptomatic infection. And those outcomes, as we're defining them, are clearance of the infection, maintenance of the infection, or progression of the infection to clinical disease. So how we're going about addressing this aim is to recruit 200 asymptomatic children at a time, aged 1 year to 8 years. We take a venous blood draw from them at enrollment that is going to then subsequently be used to characterize the host and the parasite characteristics. What we then do is we are going to follow these kids for 2 months' time with a finger prick, and as well as following them with passive case detection if they progress to clinical illness. So based on previous work and assumptions that we've made, we expected about 30% parasite prevalence in the population that we are recruiting from. So if we first focus on those kids who are initially asymptomatically infected, there are, as I mentioned, 3 possibilities that will happen with those children over the next 2 months. Some of them will remain asymptomatically infected for the entire 2-month study period. Others of them are going to clear that infection. And then the third case will develop clinical disease and progress. So we have run this cohort 3 times 200, and have a total of 600 participants recruited to date. As you'll see from this table, the Plasmodium falciparum positivity rate as determined by 18S qPCR was substantially lower than expected. We saw about 9.5% of our participants being infected at enrollment. You can also see here that the sex, the gender and the age are not significantly different from those children who were not initially infected. So what is our explanation for this lower than expected prevalence rate? One of the possibilities is meteorologic in nature. You will see here in the orange line the expected rainfall in Luwandi and Taja, where we are running this assay, this cohort. As you can see, we expect rains to start up in October, November, peak in January, and then drop in March and April for a several-month dry season until the next October and November. We planned our cohorts based on alternating between dry and rainy season. And we were somehow foiled, though, by the rains. And our cohort 3 here, which was expected to be a rainy season, we experienced a bit of a drought here in Malawi. And so we have to date basically 2 dry season cohorts and only 1 rainy season cohort. So that could explain some of our lowered prevalence. Also, as I mentioned, we are recruiting only up to age 8, and our median age, or mean age, is right around 5.5, which is a bit lower than expected, and we probably would have higher prevalence if we were looking more at the school-age children. So, but independent of how many we did recruit, the outcomes that we saw of those children that we did recruit and which were parasitemic at first enrollment was pretty much as expected. Again, we were expecting 30, 30, 40. We pretty much got 35, 33, 33. So very close to expectations. Also, again, the gender and the age, although there's slight differences, there's nothing that's statistically significant to date. So if we then go on to look at the parasitemia, again, as determined by qPCR of the 18S target, we saw that the parasite levels between the 3 groups were not significantly different, as you see here, with a median somewhere between 100 and 1,000 parasites per microliter. and included some very low parasitemias in both the group that cleared their parasites and the group that progressed onto disease. So first, we were interested in looking at these children who progressed to clinical disease. And we didn't have full data on this whole set, but those kids that we did have data on, we were able to graph their initial parasitemia and then the parasitemia at their time of presentation to an MRDT positive clinical visit, which is denoted by these purple circles. So interesting to see that some of these kids increased their parasitemia prior to their positive clinical visit, and whereas others actually decreased or remained pretty much static in their parasite levels. There were also some participants who were not infected at the beginning of the cohort, but then went on to have a clinical event prior to the end of our cohort, and we saw 10 of these kids. Again, gender and age not statistically significantly different from the other groups. When we looked at the parasitemia on these children, though, what was striking is that the speed of the peripheral parasite increase was significantly higher than in those kids who progressed to clinical disease from an asymptomatic infection. So these children in yellow, you will see shot up their peripheral parasitemia quite quickly when compared to those children who became clinically ill from an asymptomatic infection. When you look at these side by side, you'll see that those who progressed from an asymptomatic infection were increasing their parasitemia at about 1,600 parasites a day, whereas those kids who had newly detected infections were increasing their parasitemias at almost threefold a rate from the children who were asymptomatically infected at the beginning. So then we went on to look at those children who maintained their infections throughout our 2-month follow-up, and they are graphed here. Again, you will see many of them remain pretty stable with their parasitemias, although there are some who vary quite a bit. This is a log scale, vary quite a bit over the 2-month period. What was interesting to us then is to graph these different outcomes on the same axis, and you will see that the parasitemia between those who maintain their infections without progressing to disease in red and those who progress to disease in purple on this graph overlap significantly. So this is very interesting to us, and that this highlights the fact that it's not just about parasite load. For example, this child here who is asymptomatic had a parasite load of 60,000 parasites and had no symptoms, whereas the child down here had a parasite load of less than 100 and yet was reporting to the clinic with an MRDT positive clinical episode. So this is the basis for our pathogenesis study. It is that we are interested in looking at host and parasite factors that are going to distinguish this child who remains asymptomatic even at high parasitemias from this child who becomes clinically ill even at low parasitemias. So just to highlight some of our very early conclusions here, we see that the increase in peripheral parasitemia is very different among these outcome groups, with those who progress to clinical malaria from chronic asymptomatic infections being much slower at their peripheral parasitemia increase than those who have a new onset infection. And that the parasite densities in the study participants with the chronic maintenance infections are similar to those who progress to clinical disease. So you may be saying right now you haven't addressed any of your aims, and that's absolutely true. We are still just setting this cohort up, and there's a lot of things in the -80 freezer. We have not yet looked at the host and parasite features that are distinguishing these different groups. What is ongoing right now is those exact assays. We are looking at the differences in natural killer cells and Treg cells between these three subsets. We're also looking at the PFMP expression and the anti-PFMP1 antibody responses between these three different outcome groups. Also, very importantly, we're measuring HRP2 in all of these qPCR samples to try and determine if all of these MRDT positive clinical episodes are truly related to malaria, or if some of them are possibly episodes related to other clinical causes with an asymptomatic infection that has been maintained. And hopefully we'll be able to gain some insight into that based on our HRP2 levels. And also very importantly is to determine whether clonality, I mean, we are a very high transmission setting. So very important to determine whether clonality is different between any of these three groups. So that's where we stand now, and where we're hoping to be in the next six months to a year.